Hello everybody. So today we are going to talk about the Java MVC design pattern. So I'm going to give you an overview of the MVC design pattern and how it looks like and how to design the MVC pattern. What are the implementation of the MVC pattern and how we can provide a business delegate pattern to using for our business requirement. So let's not waste any time and start with our presentation. So in this presentation, we are going to talk about the client's business delegate. We are going to talk about the EGB services. We're going to talk about the history of the design pattern, and at the same time, we're going to talk about some of the useful information on the Java object classes and methods. At the same time, we will also talk about the JDBC connectors and all. So database connectivity, JDBC database connectivity. So let's start with our slides. So before we start our presentation, let me give you a brief intro about the fundamentals of the Java. So Java, like in the fundamentals of the Java, we'll talk about the object-oriented paradigm. Now, this object-oriented paradigm, the object-oriented programming, it has a few things to understand, like why we are following uh, the object-oriented programming. The object-oriented programming is a kind of critical representation of the development of the program. So if we don't understand the proper fundamentals of the Java OOP concept, will not be able to move ahead with our MVC design pattern. So what is the object-oriented programming? So object-oriented programming is a kind of an approach, that provides you a kind of a tool, a modernizing programming tool to create a defined partition of the memory. You can create the copies of your modules on the demand, and then you can define your functions, and which can be used as a template, and also you can create your copies of such memory modules on the demand. So it means that, let me explaining what does it mean. It means that, when an object is considered to be a partition area of your computer memory, that can store your data and that can set the operations, it can be accessed by the data. And the memory partitions are kind of independent. It means that the object can be used in a variety of the different programs without any kind of modifications. So let me just give you a kind of a quick object-oriented programming. Let me just explain you how does it look like. So object-oriented programming, um, okay, so yeah, so this is your oops concept. Now your object-oriented programming can have a different paradigm. It can have a kind of method. It can have uh, there can be a method. It can have a data. Now your method and data can be integrated. Like it can have a kind of, it generally gives an emphasis on the data rather than the procedure. And mostly it's a I would say it's a method with plus data. So this is how your object-oriented programming looks like generally. So it is kind of, it follows the bottom-up approach in the program design. It means that your new data and the methods can be easily added whenever necessary. So I can create a new data and new methods, and I can define it. I can have the objects. For example, let me just give you a quick example. So I have a name of a person. So this is the person is there, and yeah. So I have a person, and this person is can be further categorized. You can be a further categorized into a kind of maybe a name, and and then this person can further categorize to the not categorize, I would say a kind of he has a salary income, like a basic pay, or I would say salary. And let's not make it bold, make it simple. So salary is there, and then you can also define your, it has like HRA, and then it can define the other components like the allowances, and then we can also define the tax computation based on that. So this is a kind of a simple it's a kind of a simple object, data, and the method. So what I'm doing is that I'm defining the object here. The person is the object. This is my object, and then I have the data like the name and salary, HRA. These are nothing but these are all your data. Like let me make it italic. Yeah, so this is all your data. The three of them are your data, and at the same time, if I talk about the kind of your allowances and tax, so these are all your methods. So this is how the concept of the object-oriented programming works out. Now over here, like I'm trying to represent the entire object. This is the your representation of the object. This is a simple representation of the object, where your object is further divided with the object and the methods and data. Okay, so let's not well, this is a simple basic concept of your objects. So objects are nothing but they are kind of a runtime entities, I would say. And object oriented system, they can represent a person, they can represent a name of anything. Like it can be a kind of a person, it can be a table of data, a bank account, anything, and it can be further subdivided into other kind of item or the program may handle. So this is how it works out. And it's a kind of analyzed in terms of object and the nature of the communication between them, how they're communicated with each other. It's a kind of real world object I'm talking about. All right, so let's move on to the our slide. So objects and the classes. So and the objects, I have already defined what the object is. And when a program is executed, the objects, they interact by sending the messages to one another. In the scenario we have seen, the person, the name, the salary, so they interact with each other. And the person, the name, or the basic pay, they are the kind of a programming. The messaging services are works out, and the requesting for the balance messaging goes on, and they are kind of a balance has been set. What we have to understand is that each object, when the data and the code to manipulate the data, can interact without having to know the details of each other's data or the code. So this is a kind of one of the important features of object-oriented programming in Java. Yeah, so the second thing is that the data abstraction and the encapsulation. So data abstraction and encapsulation is nothing but how you gather the information, and then how when the data and the methods and the information is in and out has been processed. So it's a kind of a wrapping up your data and the method into a single unit called the classes, and this is all known as encapsulation. So encapsulation is like it's a kind of the feature of the class. It is it's not accessible by the outside world, but however it only those methods which are wrapped in the class can access it. That's called encapsulation. Now let me give you an example how this encapsulation works out. All right, so now I'm giving them the information. So I'm setting out the information, and information is set as I'm setting out the information in I'm setting up the information to data and the method. My data and the method has been given the information, and now this information is further sent to the information out. So my information has been given out. The abstraction, this is a kind of a simple encapsulation where the object is like the kind of a blank box. Data and the method is an object, and then I have an information in and information out. What we have to understand is that this is the data abstraction. Whenever we talk about the data abstraction and encapsulation, so data abstraction refers to kind of representing the feature without including the background of the details or the explanations. So Your classes can use the concept of abstractions and are defined as a list of abstract attributes such as the size, weight, and all. And so that's a simple thing. Let us move to the slide. Now we talk about the inheritance. Inheritance is a kind of it's a kind of a process. You have to where the object of one class acquire the properties of the objects of another class. Inheritance is the kind of a supports the concept of hierarchical classification. Like suppose you have like in the object-oriented programming, the concept of inheritance is like they provides the idea of the reusability. I have a component called bird, and the bird has a kind of different attributes like the feeders, and they lay eggs, mammals, whatever. Then I have a kind of a flying bird. They have some attributes, and they have a non-flying bird has some other attributes. And the property inheritance can be happen. Like I can give a name to that particular bird, like penguin, kiwi, or robin, or swallow, whatever, and they have a specific attributes, and those attributes can take from the different parents. It's a kind of a hierarchical classification. So that's the kind of inheritance you have. When I talk about the polymorphism, is again, it's a kind of another important ops concept. Polymorphism simply means that the ability to take more than one form. You can, for example, you have an operation that may have a kind of different behavior in different instances, and the behavior that depends on the type of the data you have and using the operation. Okay, let me give you an example. Yeah, let me give you a quick example how we am trying to create the data. Okay, so I haven't given you any example of the inheritance, so let me quickly give you an example of the inheritance. So this is your inheritance property. Now you have a specific bird, and that bird has different characters. Like it can have a characters like attributes, not the characters it can have an attributes. It can have various attributes, like it can have a feeders, it can laying eggs. So these are the attributes the bird can have, and simply this is a kind of simple attribute they have. And let me so yeah, this is a simple attributes you have, like the birds, and the birds can have a flying bird, it can have a non-flying bird. So let me sorry, I'm not able to draw that. So suppose for example you are talking about the flying bird. It can take the properties and attributes from here. Then it can have a kind of a non-flying bird. It can also have a specific attributes from here. So both of them, they can take the attributes from the parents, like from here. So this is the inheritance. They can take the character from here, and then they can further it can further segregate to the other, like the penguin, kiwi, and all those things. Let's talk about the polymorphism now. Now if I talk about the polymorphism, The polymorphism is again a kind of as I said, they take the character from the take more than one form, and they can take they exhibit the different behavior. So polymorphism is simply I have a shape to draw, and that shape can be like this. It might be a shape. Let me take the shape to draw, and I need to draw a kind of simply this is my polymorphism, and now I can have a circle object. I can give that circle to draw circle. you know okay, so I have a shape to draw, and then I can give a circle to draw, and then I can also create kind of a box object, and I can give my box. So this can be also be done. Box object integrated, and I can draw a box, and then I can give a triangular object, and I can represent it as a triangle. Yeah, so this is my kind of so this is nothing but this is my I would say kind of a polymorphism. It plays an important role in allowing the objects of different different nature, a different internal structure, to share the same external interface. This means that when you are that a general class of operations may be accessed in the same manner, even though the specific actions associated with each operations may differ. Polymorphism is an extremely useful and used in implementing inheritances. So that's the kind of one of the important aspects of the polymorphism. Our next the compile time and the runtime mechanism. Now, compile time and runtime mechanism, like, these are nothing but these are the operations performed by a compiler, such as syntactic and semantic analysis, and then you have some pre-runtime assessment of the paradigm. So that is one of the important aspects. So that's your compile and the runtime mechanism. Both runtime on the runtime is nothing but it's a kind of a time period, which is when a syntactically correct program is actually executed in the computer system, and it can be performed, the task can be performed during this time period, and they're prefixed with the word runtime of the dynamic. It can be like you can check the dynamic memory of allocation, and so one of the important concept that is associated with runtime is the implemented in the polymorphism. You can refer the dynamic binding, and so again, dynamic binding is, if I have to describe, dynamic binding, it refers to the linking of a procedure to the executed procedure to the call to its code execution and all. That's a kind of dynamic binding. It means that the code associated with a single procedure call is not known until the time of the call at runtime. It's mostly important associated with the polymorphism and inheritance. It's a kind of a procedural call associated with the polymorphic references. And lastly is my message communication. Message communication is nothing but it's a kind of a set of the object that communicates with each other. The process of programming and an object-oriented languages. Therefore, it involves the different steps. Like, first of all, you have to create the classes that define objects and the behavior. You have to create the objects from the class definitions, and then establish the communication among the objects. It's a very simple thing. You have object 1 and object 2, and then object 3 and object 4, which can be defined from the object 5. That's the network of the communication between them. So suppose I want to sending up the object to the method, and then it's created this way. So let me give you a quick reference of the same. Okay, so this is the object you have created. So I want to send this object I'm going to send this object, and then I have a messaging queue. So again, now this messaging queue can be further like again sending the object to the messaging queue, and then I have a method. So let me describe the method. So this is be my method. So I'm sending the object, and then I have described the method, and the method can be anything. I have to describe the method. It can be, so that method has been described. So this is nothing but this is a kind of your receiving object, I would say. Now this method is nothing but it's kind of a receiving object. Okay, and then you have the sending object. So this is a sending object. This is a message. This is your message, and then this you have a method, and then you have a receiving object. So this queue is nothing but is a message, and then you have a receiving object here at the end. So this is a receiving object. Okay, so this is how the messaging communication works out, you know. Let me just give you another example. If this might be a kind of a bit not bit trickier for you. So over here, so I have an employee dot salary, and let me create a quick I have an employee dot salary, and it has a different name on it. Okay, so this is the table I have now. I have a different object has been created over here. Object, then I have a message, at the same time I have the information. So the object, message, information, they are like this is an object lifecycle. The object, they can create and destroy. The communication with an object is like as long as it is alive. So what you can do is that employee is the object here, the salary is the message, and the name and the parameter that contains information. So you know, so I have a employee salary, employee of salary, and the name is information over here, you know, and the salary is the message, and the employee is the object. So this is how it goes on. Okay, so when we pass the messages, the message passing involves specifying the name of the object, the name of the method, that's the message, and the information to be sent. For example, you know, if I this is the example I have given. I am sending the object, I'm sending the name of the object, and the message, and the method, and the receiving. So receiving would be here. So that's the method through which it goes on. So over here, the employee is the object, salary is the message, and the name, that is an information. So and the salary is the message, and this is how it goes on. This is the life cycle of the object-oriented programming. And why we are doing the life cycle of the object-oriented programming? Because if you have to understand the design pattern, it's very important that we understand the life cycle of the we understand the object-oriented programming. Now let's quickly start the design pattern. So when we talk about the design pattern, now design pattern is a kind of a proven solution in a problem. Now when we have a different design pattern, like we have a kind of factory design pattern, abstract design pattern, and different design patterns we have. So what we can do is that we have to understand why the design pattern is important, and why, how come we solve the business problem using the design pattern. But before that, we have to understand a few things like the Java. I believe that the Java has a kind of an object-oriented programming, and the best thing of using an object-oriented programming in Java is to make sure that you understand the polymorphism, inheritance, and the objects and the messages in the classes. If that is not clear, then that the understanding the design pattern will be a bit difficult, because this program, this module we are going to discuss about the MVC architecture. Now, what is the MVC architecture? We'll come into the later, but before we start with that, let me just give a brief introduction, a brief history of the Java. So, a history of the Java programming, as we all know, that the Java is strongly associated with the internet, because the fact that the first application program and written in the Java was the hot Java. It's a kind of a browser run applets on the internet. What are applets? We'll talk about it. So the what we do is that how Java program came up and how we are using, because I'll be talking about the Java version 8, and then how your platform independent and the portability of the Java object, and it's very highly secure, and that's a kind of the advantage of the Java you have. So history of the Java, this program has been generally it started in the 1991 by Sun Microsoft Systems, and originally called the Oak by James Gosling, who is the inventor of this programming language Java. And Java was designed by the development of for the different TVs and VCRs and toasters and such other electronic machines. It's a kind of a goal impact of developing team which has been working on the Java, and then the Java team, they include the kind of a discovery of the programming languages like C and C++, which is limited in terms of reliability and portability. But however, when talk about the Java is like the originated with the C++ features. Some of the features are taken from the C and C++, and yeah, so this is how it works out. And yeah, so we will not spend much time on the kind of the history on the Java, because that's not the agenda. So let me start with the design pattern. So why we are using a design pattern? Now, design pattern, as we can see, I will talk about the business delegate of the design pattern. Design pattern, as it's said by the Christopher Alexander, that it's a kind of each pattern is a three part, which has a relation between a certain context, a problem, and a solution. So my model, generally my MVC pattern model, I'll just show you. Or MVC pattern model, like MVC, as we also know, which generally we have a kind of a model, we have a view, and then we have a controller. Now, what does a model, view, and the controller means in overall term? My model, generally model is nothing but model represents an object of the Java. That's just carrying the data. It can also have a kind of a logic to update controller if the data changes. So we have already understood what the object is. So the model is nothing but it's a kind of an object of the Java. So model, I can say that it's kind of an object of Java. At the same time, if I talk about the view, what is view? View is nothing but it's a kind of a representative visualization of the data. So it's nothing but again it's a visualization of the data. And my controller is nothing but, what is controller? Controller is nothing but it's a kind of one which acts on both in the model and the view. It controls the data flow into the model object and updates whenever the data changes. It updates the data, I can say, and it controls them. This is a very basic level, a very granular level to understand the ModelViewController. And I have already created a few like the Java MVC model. So I'm not going to talk about those codes and all those things. Let's move ahead with the slides. So yeah, so what our business, if I talk about the business delegate program, like the patterns, how a problems and solutions pair in the context. So what we have to understand the business requirement, not the business requirement on yeah. So what we have to understand is the business delegate pattern. Now the business delegate pattern, like it has kind of your client, you have a business delegate, you have a lookup services and the business services. Business, now this is a kind of a you don't like we don't need to know much on all these things. If I talk about the client, your client is nothing but it's the JVM, the Java virtual machines, and or your UI Java code, whichever is, like it can be a servlet, it can be a kind of a UI Java code and all. Now when I talk about the servlet, so what are the servlets and all those things, I'll come into the I'll talk about the servlets and all in my later. And if I have to give a kind of Java collections and all those things are also important, but as of now I'll not be able to discuss all those things, because that will be too many things to take care of. So I can just give a brief introduction about the Java applet programming, because that is important, and then we will move ahead with the slides. Okay, so your client is a JVM, and then if I talk about the business delegate is nothing but it's a kind of one single entry point class for the client entities to provide access to the business service methods. It's kind of would say a kind of a lookup functionality for the business tier code in the in the presentations. So this is a kind of business tier entities we have. So this is not that important, but however, it's good to know. So when does this Java? I just give a history of the brief history of the Java programming. So let's talk about the history of when this Java MVC started. Now, this like it started in 1987 by the Ward Cunningham and the Ken Beck, who were working with small tech design guys. And then the if I have to describe the history, like design pattern is a kind of a simply it's a simply I would say it's a design they can be a creational, structural, the behavioral design pattern. Now it's simply a granular like I would say it's a very granular level of like the approaches when we design the model view MVC model. So we can simply describe that it's like uh, uh, this model view pattern, like MVC pattern, subsequently, it rose, it came away, it came because of the hierarchical model view, MVA. There were a few other history. If I'm not going into the deep history of the MVC, like I have the HMVC model and then the MVA model, which are like the MVP model, and there's so many other models are there. But what is the importance of the MVC pattern is that MVC become popular with the Java development because web objects was ported to Java. So that's one of the important aspects. So that is the thing. And I have already described you the controller model and the view. So yeah. So let's move on. Let's understand the categorizing the pattern and how you categorize you know the pattern. When you have to define the patterns represent the expert solutions, how you can solve the business problem and what are the level of the abstractions you have. They have a design, they have architectural, they have analysis, they have creational, structural, behavioral pattern. Now my Java has a different design pattern. Your Java design pattern can be structural, it can be have creational, abstract. Now before you start moving into the Java design patterns, you have to understand like why you are using the different Java patterns, what are the advantages of design pattern. The design pattern generally we use because it can be used in a multiple project. They can provide the solutions that can define the system architecture. It has a kind of improve test solutions. They can be built upon the knowledge and experience of the software developers, and then we can have a design pattern that can guarantee an absolute solution to a problem. And then how you categorize the Java design pattern. Suppose I'm using a core Java J2 JAC pattern and the Java JE design pattern. So core Java design pattern can be creational design pattern. Let me just talk about because I don't want to give you a much theoretical, because I know you have to make sure that okay. So let's now talk about the design pattern. So Java design pattern can be a kind of creational design pattern. So first thing is that creational design pattern. The creational design pattern, what is a creational design pattern? It can be further divided into the kind of factory patterns. It can factory patterns. It can be divided into the abstract factory pattern. It can be the singleton pattern. Then you have the prototype pattern, and then you have the builder pattern. Now, why we are you doing a creational pattern? What are the advantages of the creational pattern and all? So, the creational pattern. When you talk about the creational pattern is a kind of a design pattern, like concerned with the way of creating the objects. These design pattern are the used when the design must be made at a time of instantiation of a class, that is creating an object of a class. So suppose I have a student record and then a student record new, so hard coded code is there. So I can, like, factory method and abstract methods and all those things will come into the picture. At the same time, we have a design, and then we have the kind of other as well. The gang of four, just wanted to give you give a kind of heads up. Gang of four is a very important. This is generally people ask, like, what is a gang of four? Gang of four is nothing but it's a kind of a design pattern element of reusable object oriented software. So Christopher Alexander was the first person who invented the above design, like the defined like design patterns, like behavioral pattern, and then you have a structural pattern. So I forgot to tell you, the creational is one pattern, and then you have a structural pattern, and then you have a design behavioral pattern. A behavioral pattern. Now the gang of four, what is the gang of four? Gang of four is a like of design pattern, like the book. It was a kind of gang of four, like it's a kind of a simple design pattern, nothing else. Yeah. So you can do much more research in the gang of four, and then you can as a design pattern. It has in C++, it has in Java, .NET, and all. So let's move on to the slides. Yeah. All right, so we have to understand the J2E, platform framework. Why we understand the J2E platform framework? Before we understand the J2E platform framework, I would like to give you a kind of a brief introduction on the Java servlets and the Java server pages. So Java server and the Java servlet pages. So let me just give a brief intro about on those things as well. So servlets, what are the servlets? Servlets are nothing but it's a kind of I would say a servlet can be defined as a program that is written in Java and then that executes in the web server based on the JVM. So servlet is created to develop your dynamic web content, and in other words, servlet can be thought as one of the applets on the server end. It's a kind. They have a kind of common gateway interface, CGI. Just make a note of it. Common gateway interface, CGI. CGI is a standard way for web server to execute web users' request to the application programs, and that retrieves the data and forwards to the users. So CGI is one of the important things, like why we are using a CGI. There are a lot of advantages of CGI. So the one of the important features of the servers, can I just understand the working of servlet, how the servlet works. Let me show you how does it works. And yeah, so let me show you how does the servlet works. So first thing is that when I'm sending the request to the web server, the concept of the simultaneous request to the server is handled by the threads. I so these are the web server. So this is my web server, and my web server, they have the web containers. I am sending the multiple requests. It's been sent, I believe, from here. um, so I'm sending the request. Let me just this is nothing, this is my request. I'm sending the multiple request. It can be okay. So I'm sending multiple requests to my web server, and then when the web container, the web server, they have the web containers. The web server, they have different threads. These threads, they send a request to the servlet, and this is how the servlet works out. So these threads, they have multiple threads, 3 threads, and they are sending the request to the servlets. So these are sending the request to the servlet. So this is the kind of work on the servlets. So this is how the web server, usually they pass the form information to the small application program that process the data and they send back to the communication messages. That's the kind of a CGI. So they work in a kind of a HTTP protocol, and then CGI can solve the same problem as the servlet, but CGI has some restrictions. So servlet, this is how it works. They have a kind of generic servlet and HTTP servlet. These are the hierarchical packages they have, and this is how it works out. So there's some kind of like the client is sending the request, and the client, they send the request and the response to the server, and the server, in the term, they create the service to the generic servlet. So in this how the generic servlets, they work out. Before you understand the servlet, there is something which is very important that you have to understand is your entire architecture. Your entire architecture generally works out in you have a client, and your client, then you have a web layer, and then you have a business logic, then you have a business layer, that's the controller, and then you have this server which communicates. So this is your entire architecture works out. So entire architecture is kind of like you don't need two servers, but only one server can support you. This is an entire architecture. Entire architecture, definitely they have a kind of first layer interacting with the client on the presentation layer, and the second layer of the business logic remains as one of the core, middle layer, and the third layer acts as the link with the server and the data access layer. So the total number of the layers becomes 5, along with the client layer and the server layer, the database layer. This server layer is nothing but it's a kind of a database layer. This is the database layers, and then you can have the things. However, before that we have also have a 3-tier architecture, but the 3-tier architecture was like they have some shortcomings, it didn't work out long, so they have a cohesion between the end modules and all. So that's the reason we came up with the entire architecture. Okay, so guys, let's move on to the slide, because we have been discussing a lot of things which is not required as of now, which is not in our presentation. So let's move on. And we talk about the containers and the J2E framework and the J2E framework. So what does the J2E framework means? So before we J2 J2E has a different design patterns, and then J2E framework or JE framework, it has a kind of a presentation layer in the design pattern. They have a kind of a intercepting file pattern, file control, font control patterns, and the view helper pattern and composite view pattern. That's a kind of a presentation layer. So that's a framework. This is not a framework, but it's a kind of enterprise web-based applications, and there are 3 types of design patterns are there, like presentation layer design pattern, business layer design pattern, and the integration layer design pattern. So that's a kind of a J2E works out. And before we start the J2E, that we have to understand, as I told you, the J2E J2E, they can have a kind of server side applications and the framework. So J2 platform enterprise edition can have a kind of it's kind of advantages. A lot of challenges which is faced by the developers, and that's the reason the J2E has been used. And how the J2E framework works, when we write a code that makes use of the core technology in Java, J2E, they compile and they deploy the enterprise archive file to an application server. So that's one of the advantages. So we have a EAR file, then enterprise archive file, which works out with associated bytecode and results associated with it. And the J2E runs on any OS applications. It has a plethora of enterprise features, and it works out in that way. So if you want, I can just show you the J2E how the architecture looks like, and yeah, that will be good. So let me just show you the J2E architecture, so that you will have a fair amount of the idea how it can be works out. Now my J2E architecture have a client tier, as you know. So it has a client tier that consists of the users, programs, and interact with the user for the request and response. So let me just quickly go ahead and write. It is a client tier, and then with the client tier we have a middle tier. And then we have an enterprise data tier. I'll explain you what all these means. It's almost similar to the entire architecture. So the J2E application architecture has the client tier has what the users interact with the response and all. And the middle tier is like usually they contain the enterprise beans and web services that distribute the business logic for the applications. And then enterprise data tier, like enterprise data is stored in relational databases, and this contains the components and all the kind of different services and all. And so if I have to give you a graphical representation of the J2E architecture, so I have a browser, and the browser will interact with my JSPs, the servlets, and the web containers like EJBs and all those things. And then the J2E servers have the EJBs and web containers, and then it will also connect with my databases. Let me just quickly go ahead and design that as well for you, so that you can have an understanding. So this is nothing but this is my client tire. My client tire includes, it includes the browser. It can also include the application client, different other applications you have. It can also use the application client containers as well. All right, so this is how this is a client tire. Now with the client tire, we can the next thing we can have is that so this is not my client tire, but this is my middle tire. Now middle tire will have all kind of your JSP servlets and all those things. JSP, it can have your servlets, it can have your web containers, like EGBs and all, and it can also have your J2E server, and this is your middle tire, and the next thing is your enterprise data tire. Enterprise data tire will have the database server, so it's your it can be a kind of Postgre. Yeah, Postgres is fine. PostgreSQL is okay. So this is your kind of the enterprise your architecture, the graphical representation of your J2E architecture. So you have a client tire, you have a web client, and you have applets. Applets, like they are the web page received from the web tire and embedded in the applets. So what are the applets? I believe I have to go through the applets as well to make you understand. I'll just give an overview of what are the applets programming and how the applets differ from the applications. So applets programming, they have a different I would say the applets programming had the different kind of how I will just give you an overview how the applets started. What are the local and the remote applet, what are the applets started. The applets are the small Java programs. They are primarily used in the internet computing, and they can be a kind of transported over the internet from one computer to the another and run using the applet viewer. So it's a kind of applet can be kind of a local and the remote applets. So local applets can be on local computer, and then loading of the applets can be happen, and then remote applet can happen with the remote computer server. So how applet is different from the application is the applets, they do not use the main as a method for initiating the execution of the code, and they are generally kind of applets are restricted from using libraries, and applets cannot run on any program from the local computer. So these are a few of the differences you have. I hope there are others, but this is a kind of a basic thing, and when to use applets and how an applet works and all those things will not go on to all those things because we are not discussing applets as of now. That is not the agenda, but however just a basic things is that we can initiate an app like initializing state, and applet lifecycle is there. So that we can create an running state and try data, destroy the state, and also those things are there, like how we build the applet codes and all those things are there. So we'll talk about applets. We can talk about applets some other time. Let us move on to some other the J2E components. We have already talked about the EGBs and web servers and servlet containers and bean controllers and web containers. So these are connectors. The connectors are the service providers. So we have already given a architectural view of the J2E. And the J2E components like enterprise EGBs and JSPs are there. So EGBs are nothing but enterprise Java beans. So EGBs, they are like the J2E server, then the results are processed the client tire, which prompts the input user to request is forwarded. So the EGB helps. EGB doesn't come to the picture here. EGB will be kind of I would say it's a kind of a enterprise. It's like specifications which helps to create the scalable distributed platform. It's mostly help you to understand how your EGB, the stateless region, the beans, and all those things that have been created. So I will just create another presentation on the EGBs, and it's a huge topic. So you just need to understand that these are all the component to communicate server and all. I have already given a presentation on this logic, how your client-side presentation, your browser, your desktop, all the services or applications are connected with server side. And the server side is nothing but JDP platform, EJBs, and all the JSPs and all. EJBs and JSPs, I'll give a presentation on some other days, and then your enterprise databases. So I have already given a presentation on the same similar kind of thing. So let's move on the J2E and the design pattern. So J2E and the design pattern is I have already given you the understanding of the presentation layer design pattern, the business layer design pattern, and the integration layer design pattern. Let's talk about the J2E architecture tier. So the client tier, I have already told you, the web tier and the EGB tier. So these are the tiers we have. These are nothing but it's a kind of a similar kind of thing which I have been talking about, the client tier, middle tier, and the database server. So this is your client tier. Client tier is the browser application, client applications, and all those things. And then you have a middle tier like JSPs and all. And then you have a databases. So this is how it works out. So what does a client tier do? What client tier is responsible for presenting the data to the user, like the interaction with the users and communicating and all. So a client tier nothing but it provides the flexibility. What does it only possible in the J2E. Why a client tier is important? The client tier is is important, because the client they kind of your application client that access a J2E server, and they are usually located in a different machine from the server. So that's the reason client tier is important. The client tier, what they do is that the platform is designed, the J2E platform is designed in such a way that the developers can create a large scale and a multi-task scalable, reliable, and secure network applications. So your client tier would help you to understand the the Java 2E2 server, and the usually located in a different machine from the server. The client makes request to the server. So what happens is that the server processes the request and return a response back to the client. That's one of the important thing. And then we have the web tier. Web tier is again an important, like they are dynamically generated the content in the various format. So that's in web tier. So web tier is like they collect the input from the users of the client interface, and they return the thing. So that's a kind of a web tier Java application. They kind of they perform the simple basic logic, and they hold some data, and they maintain the state of the data from a user session and all. So web tier, they take care of all those things. So I have given a pet store. So pet store is like it's a kind of a simple application which I've created, but I haven't included it over here. And so what are the importance of the MVCs? Like MVC's model, like important is that the MVC model there they can have a kind of a simple, model view components can vary independently, and they can have a lot of advantages. The few of the advantages I have already talked about, like the model view and controller. So model is responsible for managing the data of the application. It receives the user input from the controller, and the view that renders the presentation of the model in a particular format. So what motivates us to use use it, because when I'm using this kind of model, the software pattern MVC express the code of the solution to the problem, and it helps us to adapt in each system, and it kind of facilitates the new types of data and presentation of the technology to the developers, and they can create this kind of framework. And this framework came from the Django and the Python, and but however they strongly emphasis on the rapid development, and the MVC's popularity has been moved ahead of the traditional applications, singleton applications. So there are a lot of other thing, or people might ask you, why don't I use the singleton applications and then MVC? So singleton page versus the kind of singleton application and then MVCs. Singleton will always will have a kind of singleton application will always have you some kind of drawbacks in, and that the design pattern depends on MVC design pattern mostly depends depends on kind of how your business and logics looks like. So based on that, you can go ahead and create your MVC design pattern. And the MVC design pattern, there is a clear separation of the business logic and presentation logic and the data. And there is a front end view presentation layer which is viewed by the users and then back into the model data. So this is how your, and then you have a middle tier controller. So as I explained you in the middle tier and all those things, I have already explained you all those things. So MVC, how the middle tier, front layer. So so just go through these slides and see how it looks like your client web layer and entire architecture. It's a kind of all similar kind of thing. It's almost similar kind of thing. Your MVC design pattern. So your enterprise business logic is there, and then you have defined that. So that's the reason. Singleton, generally singleton and observer MVCs are the three different kind of patterns you have, and then the singleton design pattern comes under the category of creating a design pattern, and then only one instance of the data is created, which is used by all the colors. So that's the reason. And however, observer and the MVC kind of category of behavioral design pattern. So you have to understand what is that behavioral design pattern and all. I have already explained you about the factory regional design pattern, structural design pattern, and behavioral design pattern. So behavioral design pattern, if I have to explain once again, my behavioral design pattern will have a kind of chain of responsibility. It can have a command pattern, interpreter pattern, and then iterator pattern, mediator pattern. So all those things are there. So behavioral pattern works in this way. So before we move on to the behavioral pattern, I have to understand that why behavioral pattern, why you need a behavioral pattern, what are the advantages of behavioral pattern. Behavioral pattern design is like they have 12 types of behavioral pattern, renal objects and template patterns and all those things. You have to understand the objects behind it, why you're using it, and what are the advantages. Some of the advantages have already been described in the slides, so make sure you just go through that and then understand it. So consequences of the benefits, we make changes to the bringing down the server. We can leave the code alone. We can have multiple versions of the same data. We can use the different kind of applications, and they can be sequential, can be test our changes in actual environment and as well. Make sure that you have a CI/CD pipeline integrated. And I have already gone through all those things, EGBs and EGB. I'll go through a separate slide. So yeah, so over here the MVC structure for the J2E, they have a browser, they have the request response. I'm sending a request to my controller, and then I'm viewing the data of the JSP, and then my Java bean has been able to integrate with my enterprise server. So over here you have to understand one thing in the Java beam is how my applet programming is working, the HTML, aligning the displays and all those things. And one thing which I would like to talk about, I would have already explained you the entire architecture. Now if I'm talking about the features of the servlets, so that's one of the important thing. Why the features of servlets? So we are talking about the servlets for a long time. Let's talk about the features of the servlets, and then I'll end this presentation. Now features of servlets, one of the important features is that portable. It's known as a very portable because since a servlet can use a Java as a programming languages, and Java is a platform independent, so servlets are platform independent as well. It makes a servlet portable, and then that they work on the basis of they can work on the Windows operating system, and later it can be executed on any other operating system like Unix and Linux or the web server. So that's kind of the portability. It's very highly efficient and scalable. Scalable in the sense it can be a kind of like once a servlet is deployed and loaded on a web server, it can instantly and start like fulfilling the request of the client, and then it can web server invoke the servlet in a lightweight trade. So that's the reason it's highly scalable and very efficient as well. It can start performing in the first instant as well, and it's very robust as well. When I say robust, It means that it's kind of a servlet has no memory leakage. That's one of the important thing. It has no memory leakage. It's one of the important thing is that it's in the servlet, because servlets, they inherit the features of Java and the Java garbage collection, Java exception handling, and Java security manager, and then they create the development of the web application in the servlets that's secure, is less error prone. That's the important thing. And the servlets, so that's the important thing of the servlets you have. And well, that's it. I don't have anything to discuss. If you have any questions, you can surely put on the comments, and then I would be able to check it, and then I'll be able to describe. Then if I'll just give a brief about the JSPs, because JSP is also included in the model. What are the JSPs and why we JSP is preferred over the servlets? So JSP is the ensure a kind of easy way to incorporate the dynamic web pages, and JSP is nothing but JSP is Java server pages. JSP is nothing but the Java server pages, and JSPs are always advantages of the servlet, because JSPs, it does not need any kind of extra Java class files or the Java web.xml files and all. And JSP does not require any kind of compilations. And that's one of the advantages of the JSPs. And JSPs are like easy to code, and the platform portable as well. I would talk about the life cycle of the JSPs in some other presentations and all. So as of now, JSPs, like, they have the web container application server, and then they translate JSPs code into the servlet classes .java file, and that's how it works out. So that's the kind of life cycle of the Java. I'll talk about the JSP commands and the different scripts and all those things. Will be coming to I'll talk about all those things in my next presentation. And so I hope I was able to explain you about the MVC architecture with the J2E. And in my next presentation, I'll take you to some other like the EGBs and all those EGBs and JSPs, and the life cycle of the JSPs, and how the JSPs, example of the different JSPs, and how the directive tags and all those JSPs work. At the same time, I'll also take you to the applets and servlets, like some more the brief some more details overview on the servlets and applets as well. So till then, just go through these slides and let me know if you have any doubts. I'll be good to connect. You can put your comments on the comment box, and then I'll get back to you. Okay, till then, yeah, thank you, and have a good day ahead.